Hi everybody, this is Mr. Schaefer again. Just going to go through the end of Unit 4 test, the statistics stuff. This is material which you should find relatively straightforward, and there's a good place to pick up marks. Okay, so launching straight into it. Question 1, we've got a two-way table. Doesn't look like we've got that much information, but actually there's more than enough to complete the table. Of the 200 people, 90 were female, so we put 90 in there, which means that 110 must have been male. 60 people were unemployed, including 20 males. So 60 were unemployed, 20 of whom were male, which means that must be 40. This must be 50, so that we can sum the females sum to 90, and that must also be 90. So the males sum to 110, and that must be 40, and you can do a double check that 60 and 140 sum to 200. Excuse me. Right. That's worth 3 marks. Basically, you lose 1 for each error in the table. Okay, next we've got to find the probability the person is an unemployed female. So an unemployed female is this box here. So the probability that they're unemployed female is 40 out of 200, which you can simplify to 1 in 5. And then a male, given that the person is employed. Now, given that a person is employed, implies we're only looking at this line here. So we have 90 out of 140. Which equals 9 out of 14. And I apologize for my writing, but my pen is lagging substantially. Okay, those are worth 1 mark each. So 1 and 1. Question 2, this is a question that tries out for a sample space, which is what I've done here. So this is the first dice here along the bottom. This is the second dice along here, up here. And these are the sums. If you roll a 6 and 6, you get 12. So we're looking for, first off, that the probability is that S is less than 8. So P, S less than 8. So we are looking for anywhere where the sum of the 2 dice is less than 8, and that is all of those items that I've underlined, which is 21 out of 36, which will simplify to 7 out of 12. At least 1 dice shows a 3, means that we are now looking for where the rows and columns where there is a 3. So there's a 3 anywhere in here. There's a 3 anywhere in here. But one of those is double counted. So we only want to count that once. So instead of being 6 and 6, this is actually 6 and 5. So P minimum 1, 3 is 11 out of 36. And finally, we'll ask to find the probability of minimum 1, 3 given S is less than 8. So we're now only looking for the ones with the blue underline. So we're looking to say how many of them have a minimum of 3, which is 1, 2, 3, 4, 5, 6, 7 out of 21, which reduces to 1 in 3. Marks wise, that was 1 for that, 1 for that, and 2 for this. Question 3. First thing we need to do is, it's a single line, but we've got 6 marks for this, so we're going to have to do a little bit of work. I would do this like this. I would say let the probability that A happens equal X, which tells us that the probability that B happens is equal to 2X. The probability of B is 2 times the probability of A. We know that the probability of A union B is the probability of A plus the probability of B less the probability of A intersection B. That would be where it would be double counting. So probability of A union B we know is 0.52, and that's equal to the probability of A, which is X, plus 2X, take away 2X squared. We're told that they are independent, so we know the probability of A intersection B is the probability of A times the probability of B. So this gives us a quadratic, which is 2X squared minus 3X plus 0.52, which you can solve any way you like. You can use the quadratic formula, you can use a calculator, whatever. My default is always to try to factor first, and that gives you X minus 0.13, not 0.13, 1.3. Which, by the null factor rule, gives us that X is equal to 0.2 or 1.3. And we can get rid of that because the probability can't be more than 1, so we can discard that, giving us the probability of B is 2 times 0.2, which is 0.4. So marks here, you got 1 mark for basically using this and then constructing that equation somehow. 1 mark for equating it to 0, 1 mark for solving it by any means necessary, and then 1 mark for finding X and 1 mark for finding the probability of B. Question 4, the letters of the word probability written on 11 cards are shown. 2 cards drawn at random. Probability of A is, how many A's are there? 1. How many letters are there? 11. Not too tricky. 1 mark for that. Part B, the probability of B happening, given that A has happened, means we still have 2 B's in here, but we now only have 10 cards because the first one has already been taken, which is equal to 1 in 5, and that's 2 marks there. 1 mark somehow for indicating that you know that something has already happened, probably by indicating that that's 10 cards left rather than 11. Third part, probability of B happening first, is that is 2 out of 11 because there are 2 B's out of the 11 cards, and the probability that A happens given that B happens is then going to be 1 in 10 because there's still only 1 A and there's now only 10 cards left. So again, 1 mark for that. Apologies, 2 marks for that, and 2 marks for that. I'm not quite sure how they justify 2 marks for that, but take them. Question 5, in a given football season, football team plays 65% of their games at home. So when they play at home, they win 83%. When they play away, they win 26%. They play 1 game. Find the probability that the team wins the game. So the probability that they win the game, PW, is going to be 0.65, the percentage of their games they play at home, times the percentage of their home wins, plus 0.35 times 0.26. And you put that in your calculator and you get a percent, you get a probability which is 0.6305. 1 mark for that part of it, 1 mark for that part of it, and 1 mark for the answer. Then we're going to find out if they do not win the game, find the probability that the game was at home. So the first thing you need to figure out is what's the probability that they don't win. The probability they don't win is 0.396, sorry, 3695. Which you get by doing 1 take away that, because if they don't win, if they win, that's the probability. So the probability they don't win must be the complement of that. Once you've done that, you can then do the probability that they are playing at home, given that they don't win, is equal to 0.65, which is the probability that they played at home, times 0.17, which is the probability they don't win when playing at home, divided by the probability that they didn't win in the first place, because that's a given. And that equals 0.2991. And 1 mark for the probability of not winning, 1 mark for this construction, and 1 mark for the final answer. Question 6, Venn diagram, very straightforward. Write down, so you can just write these answers down, no calculation needed. PA is 0.5, intersection is 0.3, so P must be equal to 0.2, they must sum to 0.5. Similarly, these sum to 0.7, so Q must be 0.4, and R must be whatever is not in both of these two, so R must be 0.1. 1 mark for each. Probability of A given B prime. A given B prime, it's outside of B. So we don't care about any of that. What we're looking at is the probability of A given B prime is 0.2 divided by 0.2 plus 0.1, which is 2/3. Because we're only looking at the regions involving P and R. And otherwise, hence or otherwise, generally hence is a good way to go, show that the events of A and B are not independent. Now we need to show that P of A given B prime is not equal to P of A. And P of A given B prime is 2/3, and P of A is 0.5, so 2/3 is not equal to 1/2, therefore not independent. Question 7. An influenza virus spreading through the city, vaccination is available, blah, blah, blah. Find the percentage of the population that has been vaccinated. Well, let's start off by saying the probability that somebody is vaccinated is X. Then that gives you the probability they are not vaccinated. That prime is equal to 1 minus X. So from that we can form that if they probability of catching the virus is 0.1 if vaccinated, so 0.1 X plus 0.3 times 1 minus X is equal to 0.22. And you can work all that through. That's a simple linear equation. I'm not going to do every stage of that, which gives you that X, which is equal to the probability that they're vaccinated, is equal to 0.4. And you get 1 mark for back probability of back prime, 1 mark for setting up that, well, 2 marks for setting up that equation, and 1 mark for coming up with an answer. That's part A. And part B, randomly chosen person catches a virus, find the probability this person has been vaccinated. We need to find the probability that they are vaccinated, given that they have the virus. and that's equal to probability to 0.4, the probability they're vaccinated, times the probability that they have the virus, divided by the probability of being vaccinated, which is the expectation that they have the virus is 0.22, and that comes to 2 out of 11. 2 marks for setting that up, one for the numerator and one for the denominator, I suspect, and 1 for the final answer. Question 8. This is beginning to get a little bit trickier, not hugely. We've got 2 different bags. Bag A, 2 red discs, 3 green discs, 2 chosen at random. Find the probability that 3 red discs are chosen without replacement matters. So the probability of red is 2 in 5 times 1 in 4, which is simplifies to 1 in 10. 1 for setting that up, 1 for the answer. Part B, which is also the probability of red, but it's the other bag, is we only know there are n green discs. So probably if you're getting a red disc is 4 out of 4 plus n, multiplied by 3 out of 3 plus n, and we know that's equal to 2 out of 15. So again, we need to find a method to solve this. So let's make this a single fraction to start with. 4 times 3 plus n. Sorry, what am I talking about? We're not adding that. I'm multiplying. It's a lot simpler than I'm trying to do. Multiply, so 12 over 4 plus n, 3 plus n equals 2 out of 15. And you can work that through until you get to a solution, which is that n equals 6. There are other ways of doing that. Any valid method works. Any valid method will score the mark. So 1 for the answer, and 1 for the 2/15ths, and 1 for setting up that equation, or attempting to set up that equation. Part C, which is that calculate the probability 2 red discs are chosen. Well, the probability of that is that is 1/3 times 1/10, because this is after you rolled a 1 or a 6. You get 1 or a 6 is a 1/3 chance of choosing from bag A, sorry. Now 1/3 times 1/10 plus 2/3 times 2/15ths, which comes out to 11 out of 90. Again, 2 marks for that, 1 for setting up the equation, 1 for the final answer. And the last part, which is the probability of that you used bag A, given that you've chosen 2 reds. This is a little more tricky, but the probability that you're going to get 2 reds out of bag A is that. So it's 1 out of 30 divided by the probability of getting 2 reds at all, which is 11 out of 90, which gives you the final answer, 3 divided by 11. That I think takes a little bit of thinking about. So 1 for setting that up, 1 for using the right numbers, and 1 for the final answer. And question 9, discrete random variable x is defined in the table. You know a couple of things about this. So you know that the probabilities must add up to 1. So 0.1 plus 0.1 plus 0.25 plus 0.3 plus a plus b is equal to 1. Gives you a plus b equals 0.25. And then we know that within the expectation 1 times 0.1, I can ignore the 0 times, plus 2 times 0.25 plus 3 times 0.3 plus 4 times A plus 5 times B is equal to 1.1. And we have simultaneous equations there, which we can solve to find B is equal to 0.1 and A is equal to 0.15. And marks for that are 1 for that equation, 1 for that, 1 for simplifying it to that, 1 for this equation, and simplifying that final equation to 4A plus 5B equal to 1.1. And 1 for solving the equations, find a method for solving the equations, and 1 for each of those answers. And there you have it for a total of 60 marks. Okay, I hope that helps, and get in touch if you need any further explanation.